Hi, I'm Jonathan Amy, and we're back again with Clay Starlin. He's going to be talking about the standard learning chart. Hang in there with this one. He's going to explain it all. But Clay, please take it away.
Thank you, Jonathan. Welcome to the presentation on the standard learning chart. It's critical that we have a standard learning chart in order to better inform educational decision making. This is our standard learning chart. It's the only learning chart that enables you to visually quantify frequency, learning slope, and bounce, the educational units of measurement that we discussed in a previous Heart the Chart Foundation series video. Here's a little history about the chart. There is a family of charts. They're daily, weekly, monthly, and yearly. We're going to focus on the daily chart. That's the one used primarily in educational instructional settings. The technical name for the charts are the standard acceleration charts. Acceleration basically being a synonym for change. The charts were developed by Dr. Ogden Lindsley with contributions by a number of his students. First published in 1967, the 2020 version is revision number 14. And paper charts are available from the Behavior Research Company. There are three essential elements of an accurate learning chart. We need a real-time scale, and the standard learning chart has a successive calendar day scale here, which is 140 days, which is 20 weeks. The lines that go up and down are the day lines. Monday through Saturday are thinner lines. There's a little key up here in the upper left-hand corner. And the thicker lines are Sunday lines. The advantage of a real-time scale versus something like a session scale, where sessions would be number of sessions in a given day or week, but you don't know the actual calendar time. In order to get an accurate learning slope value, we need real time, because you need to know how much time was spent in the learning process. So that's an important aspect of a real-time scale. Another aspect, if a student happens to be absent from an educational setting like a weekend, holiday, or sick day, there's actually a place on the chart to chart information at home, if that's a possibility. If there isn't any charting done at home, it's interesting to be able to see the gaps in the data, where you can look at data before and after a weekend or before and after a vacation and see if there's been any impact, either positive or negative, from being away from the educational setting. So it's really important to have a real-time scale. So that's one of the critical elements of a standard learning chart. Second one is we need a frequency scale or a count per minute scale, which frequency being our most sensitive measure of level of performance. So the lines that go across the chart are the count per minute or frequency lines, ranging from 0.001 or 1 in 1,000 minutes, which is basically 1 in a waking day, up through 1 a minute, up to 1,000 times per minute. So here's a few plots to kind of give you an idea of how the intersection of the frequency lines and the day lines function. So here's 0.005, which is 5 in 1,000 minutes on a Friday. Here's 0.2, which is 2 in 10 minutes on Sunday. Here's 19 per minute on a Saturday, and here's 600 per minute on a Wednesday. So that gives you sort of a view of how the frequency lines and day lines intersect when you're plotting data. Here it kind of shows you some of the different skills that their frequencies tend to show up on the chart. You notice in the upper half of the chart in purple, these are primarily academic skills. And in the bottom half in red, these are primarily personal social skills. So one of the real powers of the standard chart is you can chart all behavior, any behavior you want to look at in a waking day on the same chart. So the third major element that you need in an accurate learning chart is it needs to remain standard. So here's an example of pictures that indicate that as you look at the learning slope lines, you would assume that they are all the same, but when you look at the vertical and horizontal axes, you notice that in fact they are not. So one of the popular spreadsheet programs, Excel, actually does this to your data, and therefore it makes it very difficult to really interpret in a standard way what a learning slope line means. But the standard chart is, because it's standard, when you bisect the right angle or any other learning slope value, you will have a standard value. So it's important that you can trust that the line you see represents the same thing each time you're looking at a chart. So as compared to these, where you realize that in fact these lines are all representing different amounts of growth. The chart has 6 sections that are represented here by the arrows. And you'll notice that as you go from the bottom to the top of each section, the lines tend to squeeze up, and that's because it's a multiply scale. So one of the differences between an add and a multiply scale, a way to kind of conceptualize that difference is to think of people of different ages. So here's a person like a 1-year-old versus a 20-year-old, or a 60-year-old versus an 80-year-old. So most people would consider that a 1-year-old and a 20-year-old are more different than a 60 and an 80-year-old. But in the add world, they're the same because they're both 20. But in the multiply world, a 1-year-old versus a 20-year-old is times 20, and a 60-year-old versus an 80-year-old is just times 1.3. So if we represent that graphically, here's actually an add scale. You see from 1 to 20 and 60 to 80, the slope lines are the same. But when you put it on the standard multiply scale, times 1 to 20 is a times 20, but 60 to 80 is just a times 1.3. So a very different picture of change. So one of the powers that gives us is we can actually see how rapidly students are learning. So here's an example of if a student was at 10 and moved to 20 in 1 week, that would represent a times 2 per week, because as we said, we determine learning slope based on per week. But if it took 2 weeks to get to double, then that would be only a times 1.4 learning. 4 weeks would be 1.2, 8 weeks 1.1, and 16 weeks to double would be 1.05. So this is a real power of the standard chart. It enables us to actually visualize how rapidly a student's learning, which of course informs our educational decision making about what kind of interventions we may want to maintain or change. Here's actually a completed project with a kind of a classic learning sequence. This is Jake, who's 10 years old, who's thinks fact, says fact, which is a retell process. So Jake reads an article and then summarizes orally his performance. The dots represent corrects and the X's incorrects. So Jake starts around 10 correct with a couple errors. So this is kind of the accuracy building phase. With some interventions, we get some nice growth in correct and some decrease in incorrect. Tried an intervention here that wasn't too successful, but then reintroduced an intervention that got him up to the mastery level, which for retell is 20 to 30 facts in a minute. So Jake got for a little over a week, stayed right in that mastery correct range. And this represents his no errors during that same period. So we kind of start with an accuracy building phase, a pace building phase, and finally a mastery or rhythm phase. So that gives you an idea of what data would look like represented on the standard chart for one particular skill. So here's some of the most important rationale of the standard learning chart. One, makes visible the educational units of measurement of frequency, learning, slope, and bounce. Gives us the ability to see and quantify how quickly learning is occurring. Visually significant change equals behaviorally impressive change. In other words, we can see and hear times 2 change. So if a youngster read 50 words a minute 1 week and then 100 the next and 200 the next, you wouldn't need any data for your senses to detect those changes. So in essence, this variable kind of gives us what we call a social validity, where kind of objective and subjective information correspond. And then finally, we're able to display the full range of human behavior on the same chart. So that's a pretty quick overview of the standard learning, aka acceleration chart. Thank you for watching. If you have additional questions, you can contact me at this email.
Clay, thank you so much. That was a terrific presentation once again. And once again, I keep learning so much from your presentations. I appreciate it. Thank you.
You're welcome.